everyone, this is Ashika and I'm a data scientist at Data Society. We are an edtech startup company based in Washington, D.C. and we currently specialize in providing customized data science trainings to various federal and non-federal organizations, and we also work on consulting projects too. So earlier you have seen how my team uses the virtual environment in Anaconda and its packages to build deep learning models. But now I'm going to tell you how we are using these capabilities to come up with a new product, which is going to be our automated course content creation tool. This tool would be predominantly used by the data scientists at Data Society while building the content for deep learning and many other machine learning courses. So this tool will be able to take the user dataset as input, and it automatically generates a customized training course with the use cases and the deep learning concepts that the user specifically wants. So earlier, for a data science team member, it used to take almost 2 weeks for them to build content for a deep learning course. But with this new tool in place, it reduces this internal development time by almost twice or thrice for the entire data science team, which is a huge addition for us. Additionally, the tool also makes use of the virtual environment capabilities in Anaconda and its packages to generate Jupyter-based code notebooks for the training modules and the exercises which are provided as part of the training courses to the learners. The course, once published on our website, it will be made available to the learners in an Anaconda environment with all the required deep learning packages like TensorFlow, Keras, Scikit-learn, which are provided by Jupyter Hub, which runs on top of a Kubernetes cluster in a GCP environment that is hosted by us. So here's how the pipeline looks like for our content creation tool. The user initially gives the input in the form of a dataset, the topic, the number of modules, client, course, or any target variable that is associated with the dataset. The next step would be the data cleaning. So based on the type of the dataset and the use case that the user needs, the appropriate cleaning task would be performed. So if the use case is based on clustering, classification, or regression, the appropriate predictive cleaning tasks are performed. And if it's a text-based dataset, the text cleaning type of cleaning data tasks are performed. And then the same workflow is followed by the time series as well. So once this data cleaning step is done, we would have an output file which has a clean dataset. And then on top of it, we would finally run this text generation for customization script, which basically generates some customized use cases or parameters around the dataset that is completely specific to the user. And finally generates an RMD file. This we call it as generic RMD. So this file would be based on all the parameters, the customized parameters which were generated earlier. So finally, an artifact pipeline scraper runs on top of this RMD, and this would generate a slide stick in the form of a PDF format, HTML format, and it also creates a data folder with all the necessary data files. Along with that, a code notebook is generated by making use of the virtual environment capabilities in Anaconda and the packages which are based out of Anaconda as well. So in our deep learning context, we can expect a code notebook which is based and generated using the deep learning packages like TensorFlow, Keras, etc. from Anaconda. This is how our pipeline is going to look like. Thank you.